All right, hi everybody. This is your lesson video on 6.1, the properties of exponents. We're going to go through several different exponents, properties for exponents. They do appear on your star chart, so for your reference when you're taking a test or a quiz or on star. But it's a way we follow these properties to simplify expressions when they involve exponents. So let's just get started. The first couple here, we have the 0 exponent. And for any non-zero number of a to the 0 power will equal 1. So any number raised to the 0 power will equal 1. If a is 0, it's undefined. So 4 to the 0 power would be 1. The algebraic way to write that, which would be on your star chart, would be a to the 0 equals 1, where a does not equal 0. So they didn't just make that rule up, like saying, like, all right, anything to the 0 power will equal 1. That it's actually, you can prove that when you look at the patterns of exponents. Just as a couple of examples, if we do 2 to the 4th power, all right, that would be 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So then 2 to the 3rd power is 2, 4, and 8. So that's 8. 2 to the 2nd power is 4. And 2 to the 1st power is 2. So you can see, looking at the patterns of what's taking place here as you go from 2 to the 4th power to 2 to the 1st power, it keeps getting divided by 2. All right, 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2. So then when we get to 2 to the 0 power, 2 divided by 2 is 1. And that's true for any number, all right? If we use 5, 5 to the 3rd power is 125. 5 to the 2nd power is 25. 5 to the 1st power is 5. So the pattern here, everything's being divided by 5. 125 divided by 5 is 25. 25 divided by 5 is 5. So 5 to the 0 power, 5 divided by 5 is 1. So that's how that holds true for any type of number: fraction, decimal, negatives, anything but 0, you'll always equal 1. All right, negative exponents. Sometimes we have negative exponents, and for any integer of n or non-zero number of a to the negative n is the reciprocal of a to the positive n. So when you have 4 to the negative 2 power, we take the reciprocal of 4, the base, so it's 1 over 4, and then the negative exponent turns to positive, so positive 2. So when you have 4 to the negative 2, all right, we take the reciprocal, and it's 4 squared. So then our answer here would be 4 squared is 16, so it's 1 over 16. Even when you have if it starts off as a fraction, if it was 1 over 2 to the negative 2, all right, we would take the reciprocal of 1 over 2, which is 2, and then the negative exponent turns positive, so that's 2 squared, which is 4. Notice that when you have a negative exponent, though, the answer doesn't come out to be negative. It actually makes the reciprocal. So you're not going to get a negative answer because of the negative exponent, but you will, a lot of times you will get a fraction or a decimal for your answer, but above 0. All right, let's look at a few examples together. First, with the 0 power. For a, we have 3 examples here. 10 to the 0 power would be 1. All right, b, 3 to the 0 power would be 1. And then 5.8 to the 0 power right? Anything to the 0 power would be 1. All right, so now looking at some negative exponents, we have negative 2 to the negative 4th power. So what we're going to do is take the reciprocal of negative 2. So that would be 1 over negative 2 to the 4th power. All right, negative 2 to the 4th power would be 16. So our answer here is 1 over 16. 10 to the negative 2, take the reciprocal of 10, so that's 1 over 10 to the positive 2, so that's 1 over 100. And then we have 1/5, 5 to the negative 2. So the reciprocal of that would be 5 over 1. Now to the positive 2, and that would be 25. All right, on C and D, they give us a couple of expressions to simplify. They said, simplify the expression below, write your answer using only positive exponents. So when you get like the simplest form, in simplest form, you won't be leaving any negative exponents. You always want to change your negative exponents to a positive by doing the reciprocal. So here we have things happening in the numerator and the denominator. 4 times x to the 0 power, and then y to the negative 3rd. Let's kind of unpack this, and then we can put it back together. So when we have 4, I'm going to write this as a fraction, 4 over 1 times x over 0 over 1 times 1 and y to the negative 3rd power. So you can see if we multiplied all these together, we would end up with 4x to the 0 power over y to the negative 3rd power. So now we have just 4. X to the 0 power is 1. And then for this, we want to take our reciprocal of 1 over y, so that would just be y to the positive 3. And now when we multiply across, we would end up with, and we're packing it all back in again, 4y to the 3rd. And that's as far as we can take it. But you can see it's much more simplified than it written in fraction form and rational form. All right, D, let's unpack this. We have negative 3 to the negative 3rd power over 1 times 1 over 6 to the negative 2. When we take the reciprocal, all right, that would be 1 over negative 3 to the 3rd times 6 to the 2nd over 1, taking the reciprocal there. So we have 6 over 6 to the negative, or 6 to the positive 2 over negative 3 to the 3rd. All right, that would be a 36, and negative 3 to the 3rd is negative 27, and that could reduce to negative 4/3. All right, if we're dividing by 9 here, all right, that would reduce to negative 4/3. So again, negative 4/3, much more simplified than negative 3 to the negative 3rd over 6 to the negative 2. All right, for continuing with our properties, we have product of powers property. So when you're multiplying, to multiply powers of the same base, so in this case, 4 and 4, they're the same base, we can simply add their exponents. So 4 to the 6th power times 4 to the 3rd power is, you just do 4 to the 6 plus 3 power, or 4 to the 9th power. Algebraically, what it will look like on your star chart is a to the m times a to the n would equal a to the m plus n. And we can break this down and show how it does make sense too, because if we expand 4 to the 6th power, we can do that up here. We can do 4 times 4 times 4 times 4 times 4 times 4. So there's 1, 2, 3, 4, 5, 6. So that's 4 to the 6th power times, all right, 3 more 4s, 4 times 4 times 4. All right, if we combine all these, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, that is 4 to the 9th power. So this rule is just a shortcut version of to avoid expanding them out and coming up with 4 to the 9th, where you can just take your exponents, add them together, and get 4 to the 9th that way. And then you can evaluate it from there. Okay, it's the same thing with quotient powers of property, where we're multiplying powers of the same base, we add. When you're dividing powers with the same base, you end up subtracting. So 4 to the 6th power divided by 4 to the 3rd power, we just do 6 minus 3 to get 4 to the 3rd power. And we can do that in expanded form as well to show how it works out. So we have 4 times 4 times 4 times 4 times 4 times 4. All right, that's 4 to the 6th power in the numerator, divided by 4 times 4 times 4 in the denominator. What would happen is these 4, that would cancel out, that would cancel out, and that would cancel out through division. 4 goes into 4 once, 4 goes into 4 once. And then we end up with 1, 2, 3, just 4 to the 3rd power times 1, and then we can evaluate it from there. So this is just a shortcut version where we don't have to expand it out. You just take your exponents and subtract them to get 4 to the 3rd. Algebraically on star chart, that would look like a to the m divided by a to the n equals a to the m minus n. All right, the next power property is the power of a power property. To find the power of a power, you end up multiplying the exponents. And we're not going to expand this out completely because that would be really long with 4 to the 6th power, but we can do 4 to the 6th power times 4 to the 6th power times 4 to the 6th power. And by following the product powers where we add, all right, we're adding those. So that is 4 to the 18th power. So the shortcut with the rule, when you have 4 to the 6th power to the 3rd power, you end up multiplying those exponents to get 4 to the 18th power. On star chart, it would be a to the m power to the n power is a to the m times n. All right, so let's look at a couple of examples with the additional power properties. Simplify each expression. Write your answer using only positive exponents. So that's the simplified form. So we have 3 to the 2nd times 3 to the 6th. They are the same base, so we can follow the property. So that becomes 3. We're just going to add our two exponents. So that's 3 to the 8th power. And then 3 to the 8th power would be 6,561. All right, B, we have negative 4 to the 2nd divided by negative 4 to the 7th. We would do negative 4 to the 2 minus 7, so that is negative 4 to the negative 5th. We have a negative exponent there, so we don't want to use that. We're going to take the reciprocal of negative 4 to the 5th. And negative 4 to the 5th is negative 1,024. And then C, z to the 4th to the negative 3rd. We were going to do z, and then it's 4 times negative 3, so that is z to the negative 12th. So we wanted a reciprocal of z, so that's 1 over z to the 12th, and that's as far as we can take it. We can't evaluate that any further, so it's 1 over z to the 12th with a positive exponent. All right, our last couple of properties here. One is the power of a product property. So when two things are being multiplied and then those have an exponent, you're kind of doing the distributive property here with that exponent. So the 5 goes to the 3 to the 5th power and then 2 to the 5th power. So we have 3 to the 5th power times 2 to the 5th power. And then you would follow the product rule. These aren't the same bases. So you would just do 3 to the 5th, 2 to the 5th, and then multiply. But when you have an exponent with product, an exponent with a product problem, all right, you want to distribute that exponent to each term within the product. So a times b to the m is a to the m times b to the m. All right, same thing holds true with division. If you have 3 over 2, 3 divided by 2 to the 5th, all right, that's 3 to the 5th divided by 2 to the 5th. The algebraic writing with that, a divided by b to the m is a to the m over b to the m. All right, let's look at a couple of examples with these last couple of properties. We have negative 1.5y, both to the, times y to the second. So we're going to distribute that exponent across. So that is negative 1.5 squared times y squared. All right, negative 1.5 squared is positive 2.25, and then y squared is just y squared. And that's as far as you can take that. Here we have division. We have a divided by negative 10 to the 3rd. So we're going to distribute the exponent to each. So that's a to the 3rd divided by negative 10 to the 3rd. We can break this apart a little bit. We have a to the 3rd over 1 times 1 over negative 10 to the 3rd. I guess we didn't have to do that. I thought that was a negative 3, so just forget about that. We have a to the 3rd, and then negative 10 to the 3rd is negative 1,000. All right, 3d divided by 2, all to the 4th power. So this would distribute to both the 3 and the d, and then also to the 2. So we have 3 to the 4th power, d to the 4th power, 2 to the 4th power. So 3 to the 4th power is 81. D to the 4th power we're just going to keep. And then 2 to the 4th power is 16. This can't reduce. If it could reduce, we would. But we're just going to keep that. This is simplest form, 81 d to the 4th over 16. All right, D. Again, just like on C, right, that negative 5 distributes to each term here. So that's 2 to the negative 5 and x to the negative 5 over 3 to the negative 5. Now this one let's break this one up. All right, sorry about that. So then we have negative exponents here. So let's break this apart. We have 2 to the negative 5 over 1, x to the negative 5 over 1, times 1 over 3 to the negative 5. Now that we have these negative exponents, we want to take the reciprocal, so this becomes 1 over 2 to the 5th, and 1 over x to the 5th, and this is 3 over 1 to the 5th. All right, so now when we put it back together, we have 3 to the 5th over 2 to the 5th, 2 to the 5th, x to the 5th. Now, simplify this further, I'm going to go up here with it. 3 to the 5th is 243 over 2 to the 5th is 32. And then x to the 5th we just keep as x to the 5th. If 243 over 32 reduced, we would want to do that. But this is in simplest form, so we are done at this point. All right, that's it for your lesson video for 6-1 properties of exponents. If you're still having questions about it and you need help getting started, be sure to check out the homework help video where you can catch some other examples being done for you with the explanations. But if you're feeling comfortable, go ahead and start the homework. And then if you have additional questions, bring those to class. All right, have a good night. Bye.